decimeters by what, Jeff? I don't know, 400 millimeters by 0.02 decameters. And let me see who can do this. I want to know what's the volume in liters.
In liters?
Yep. So of course, there's nothing here directly related to liters, right? What is directly related to
You
liters?
gotta convert it.
Meters, but they're all in
Decimeters, right? So you think ahead. You say, okay, the strange student that teaches this class wants me to go to liters. What gets me to liters is here. You got to look ahead. I want to be there. What gets me there directly? These two. So of course, what do I want every side to be in? Decimeters, because that'll lead me directly to liters. That's a huge part of conversion, is knowing where you are and where you want to be and what connects the two.
So why wouldn't we just go straight to liters? Why wouldn't we just convert all these numbers, decimeters, millimeters, and decameters to liters?
Because liters is volume. This is a length. A length of something can't hold water, right?
No.
How much water can that line there hold? None. I need all three together. Cubic decimeters holds water. A little box will hold water, right?
Okay.
I don't want to try to hold water on a record.
So instead of getting it
Thing,
to
right?
liters, we need to get it to what?
Does everybody understand that? I do have that every now and again. I have somebody trying to convert each side to liters. That makes no sense. Liters is a volume element. I have to convert it from something that's volume. What's volume? Cubic stuff. So I need to make each of these decimeters so that when I multiply them together, it'll end up in cubic decimeters. And that's exactly what liters are, right? So how big is this box volume-wise? And again, I could go to anything I want to. I'm going to go to decimeters. Why? Because I know that decimeters leads me to liters. Right? So I'm going to be smart about what I convert my stuff to. Oh, those are my good ones? That sucks. So this is already decimeters here. 400 millimeters is how many decimeters?
4.
Good. You got to step back to centimeters and decimeters. You got to step twice, right? There you go, twice. 4. All right, you used to be good. What happened to you? 4 decimeters there. 0.02 decameters. 2 decimeters. So the volume in cubic decimeters would be,
120.
careful, volume, not some kind of weird perimeter.
240 square.
How do you find volume?
Multiply.
Multiply. 2 times 4 is
8.
times 30,
240.
240. Right? If you kind of add them as some weird perimeter thing, it's not even perimeter because you haven't gone all around something. You want to multiply length times width times height. The volume of a rectangular solid. Length times width times height. And that's why it comes out to be cubic decimeters. Because what's dm times dm times dm? dm cubed. Right? And 240 cubic decimeters is how many liters? 240. Every one of these is one of those. So really what this says is if I have something with these dimensions that ends up being a cubic decimeter in dimensions, it's going to hold a liter of whatever. And I say water because then that's what makes the weight work. Because of the density issue that came up last time. Remember that?
So if we were going to convert that, let's just say you wanted the weight. So will we put it in centimeters cubed?
Well, it depends on what kind of weight I ask for. What's the weight that would go directly to? What's the weight of the water that this would hold? 240 kilograms. Because every liter is a kilogram of water. So 240 liters is 240 kilograms, right? If I wanted that. You guys with me? So if my question originally would have been weight of the water that it could hold in grams, what would you have made every side in terms of then?
Centimeters.
Centimeters, because that's what leads you to grams. You want to think about what path am I going to have to take and what does it make sense to do with what I got to get to where I want to be. So a big thing about conversions is, okay, what are the numbers involved in conversions? But even better, what's the path I want to take? Right? What path do I want to take to get to where I want to be?
You can't exactly do that with the American system.
Not as easily, hell no. No way.
Volume,
Right?
weight, okay.
I mean, to convert from like cubic feet to gallons
Would be really
is
good.
disgusting. This is true. They didn't take that into consideration when they created the system. All they cared about was how long the damn king's foot was. They didn't think about the ramifications later. They should have thrown kings into a box and said, well, the volume of that is 8 kings.
So we're basically then just converting from whether we want it length, whether we want volume or weight.
And we're converting to the thing that will lead me to where I want to be.
Are we gonna have that little thing right there?
What? Yes or no? Does everybody remember?
Yes.
Okay.
I'm going to give you a copy of that, straight out of the book, and a copy of this conversion from 8.4, which will be conversions from metric to hour system and back. And of course, that's disgusting, and that's why I don't have those numbers memorized, and I never make you guys memorize anything I don't have memorized, right? That only makes sense. All right. One more thing with this real quick. If I had a box that was 11.2 cubic meters in volume, how many grams of water would that hold? So now this is all about thinking about the path you want to take. So you say to yourself, okay, I'm right here right now. And where do I want to be? There, right? So there are quite a few ways to go. I would try to go the most direct way. I can go from here to there, right? And then from there to there, right? So every cubic meter is 1,000 kilograms. So 11.2 cubic meters is how many? Let me put my little, here's my path. From cubic meters to kilograms to grams. Cool? Maybe. So 11.2 cubic meters is how many kilograms? If every cubic meter is 1,000 kilograms, 11. So it's 11,200. So just move it over 1, 2, 3. That's a good way to do it, right? How are we doing so far? So once you identify the path you're going to take, it's not that hard after that. You just start following the path. Now, how do we go from kilogram to gram? Here's where I use my new verb. We're going to King Henry this thing, aren't we? I mean, kilograms to grams, we don't have to King Henry. Kilo means 1,000. So I got 11,200 and then another 1,000 grams. How are we doing there? Or if you like it better, from kilogram to gram, you have to go 1, 2, 3 over. Let me do it. 1, 2, 3 over. So 1, 2, 3 over, 3 more zeros. Any way you look at it, ends up with the same number. Yes, from kilograms to grams, that would be 1, 2, 3 steps over, right? So 1, 2, 3 steps over, 3 more zeros. Cool. Okay, how are we doing?
I think I'm pretty much caught on now.
What's that?
I think I'm pretty much caught on now.
Oh, okay, good. All right. Yeah.
I think I'm confused.
My head can explode.
So why did you go to kilograms? Like when you went.
Which way would you want to take me? Like, I don't have to.
Well, no, I mean I just like I know you have to end up in grams. So like, I feel like wouldn't you try and convert it to like centimeters?
That's what I
Now,
was thinking.
now the reason I wouldn't do that is because this is cubic units. You certainly could, as long as you remembered this is cubic. So normally from meters to centimeters would be 1, 2 steps.
You have to be 6 steps.
You have to remember that it should be 3 times that now for cubic meters. So it kind of makes sense why we ended up with 6 steps at the end, right? So actually it's not a bad way to go as long as you don't forget that.
Okay.
But that's just another place to make a mistake.
So why'd you go to kilograms then?
So that I wouldn't make that mistake.
But I mean, how did you get there?
Because this does lead me to thousands of kilograms, right?
And then how'd you
It's in the
get
direct
to
path.
grams?
Once I have kilograms, it's just a King Henry, just like you did here.
Oh,
Yeah.
okay.
Yeah. But there are always more than, you could go here and then go here and then go there. Right? If you wanted to, for some crazy reason.
So is the kiloliter the same Wait, no, never mind. I'm getting confused because when you're changing your path here, if you're going from kiloliter to liter to milliliter, do they all have the same value?
Well, if I'm at 1 kiloliter, how many milliliters would be? That would be a step of 6, wouldn't it? 3 to get back to liters, and then 3 to get back to milliliters.
Okay.
So again, that's a step of 6.
Okay.
But you can see this step of 6 here a lot easier than you can see the step of 6 here.
But on the bottom one, so 1 meter cubed is the same value of 1 kiloliter, and that 1 kiloliter is the same value of 1,000 kilograms.
Let me make sure you understand. This is only true, this step is only true if I'm using my favorite word. What liquid? Water. And of course, why is that?
Because the mass is different.
Because the density
Density.
difference, right? If I fill that bad boy with lead, it's going to be a hell of a lot heavier because lead has a lot more mass packed into a smaller volume, right? So this step here only works when we're talking about water, right? Don't freak out. I'm not going to make that a big part of the. I'm not going to say, no, I'm going to put Kool-Aid in there. This is not a physics class, right? We're going to stick with this. It's always going to be water that we're going to be filling these things with. It's not suddenly going to be something else.
Will you ever give us a question and tell us which path we need to take, or can we just take whatever path?
You take whatever path. And they all will lead you to the same place as long as you take them correctly. Yes.
So if we go up, it's 6 places. If we go to the right, it's 3.
No. If we go here and then go up, isn't this still 6
Oh,
places?
yeah.
From kilo to this would be 3. From this to milli would be 3 more. Cool. Here it's 6 places just because the cube triples how many steps I would normally take. Right? To me, I always kind of go from here out, just so I don't make a mistake with my cubic stuff, right? Or at least it's the way I teach it.
Sorry, guys. There it is.
Okay. There's one last thing. Is that true in section 8? No, it's in section 8.3. Okay. I think 8.2 is done. That's right. Good. So I think last time we did look at a few problems out of section 8.2, just to make sure that you guys saw what the homework was like. It actually ends up being not quite as terrible as it seems from the notes, right? I wanted you to understand the ideas. The homework is a little more straightforward, believe it or not. We did problem 111, which I think is the worst because it's such a small looking little problem, but it's got 3 steps to it. 1 coat, another coat, and then how much money is that, right? You guys survive all 3 steps. Okay, so now we're going to get into 8.3. And we sort of already have. The first piece of 8.3 is just to finish this out, because 8.3 talks about mass.